A very good morning, everyone. Today, I, Kiranpreet Kaur, is going to introduce the process of software testing. Now, in this subject, we'll start with the basic introduction of software testing. What is software testing? It is completely a process which is actually used to identify the correctness, the completeness, and the quality of developed computer software. As we all know, that software development process undergoes a complete SDLC, that is software development lifecycle, which includes 7 different phases of software development. We'll start from feasibility analysis, then we move to requirement analysis, moving further software design, development, and then we came to one of the most important phase, that is software testing of that specific software module. It is actually a process of executing a program and application under positive or negative conditions by manual or automated means. So here we conclude that the testing process can be performed by two main types. One is manual testing and another one is automated testing. Now both these testing techniques will check the specification of the software module, the functionality of your software module, and the performance of your software module, right? So before delivering the software module to the end user, it is very important to uh, test that application on the basis of some test cases so that we can deliver a good quality product. So it is actually one of the important phases which will ensure that we are going to deliver a high quality end product to the end users. Now, moving further, there are multiple objectives in the software testing process. So the major objective, the maximum, the one of the we can say the important objective is to uncover as many errors, as many as bugs in a given product. It will demonstrate a given software product matching its requirement specification. It actually confirms whether we are meeting the requirements of the end user or not. It is actually used to validate the quality of software testing, under which we have to conclude that at the very minimum cost and by using maximum efforts, we are validating the good quality product. It generates high quality test cases, perform effective tests, and issue correct and helpful problem reports. Now, before proceeding further, we must know the difference between the error, bug, fault, and failure. Now, error. Error is what? It can be syntactic or the semantic error, which is, we can say, which actually results in the incorrect result and that produces a fault. The presence of error at the time of execution of the software is known as bug. Fault, the state of software which is caused by an error. Failure, deviation of the software from its expected result. It's a failure event. Moving further, next. Now, as I've earlier discussed, the SDLC, that is the software lifecycle, software model development lifecycle, which actually is a framework which will describe the various activities which are being performed at each stage of the software development project. Now, it is necessary to ensure the quality of the software. So a software has to undergo these 7 phases of SDLC to ensure that we are having a good quality product. So we can define SDLC as the logical steps which has been taken to develop a software product. So these are the steps like feasibility study, requirement analysis, design, coding, and testing. And then we have testing is further divided into n number of testing techniques. We have unit testing, we have integration testing, we have system testing, and then we keep on maintaining the developed software product. It is the oldest and the most widely used model in the field of software development. And this model is known as classical waterfall model. At the earliest stages, This waterfall model has been used as a base model for developing any software product. Now, when we start with feasibility product, for any organization, it is important to, we can say, it is actually the feasibility in terms of finances, in terms of resources, whether that organization has the sufficient amount of resources, whether that organization has the sufficient amount of finance to handle that big project, then only it will take the project, it will take the responsibility to develop that project. After that, once it is clear that yes, it is feasible to develop this project, then the team will undergo requirement analysis. Now, this is one of the biggest stage. Now, requirement analysis involves SRS, that is software requirement specification, in which what you have to do, we have to specify the requirements of the software. Are the requirements of an end user that they are expecting from this developed product that we are going to develop, right? So we have to lay down a document. The team will lay down a document and note all the important objectives, all the requirement objectives of that software product. After having the SRS document, after having the efficient requirement analysis, then we are going to have a design phase. Before developing, development never comes like we have to start with the coding and all. Before that, we need to thoroughly examine the requirement analysis. Then we have to develop the design documents that we can say we need the flow charts, how my developed model will transfer the data from one entity to the another. So for that, when we want to show the data flow from one entity to another, we have data flow diagrams, we have a number of flow charts, we have the ear diagrams that will give us the pictorial representation that helps the developer to understand that from which node it has to move, from which node it has to provide the data flow to the another node. So this is the basis of the development. So after the design phase, we'll move to the development phase, that is coding phase. Now here the team of developers will develop the software product using n number of programming languages. We have C, we have C++, we have Python, we have Java. So all these programming languages have been used for the development product. And after that, after the successful development of this product, we parallelly start the testing procedure. Now, testing is seems to be very simple, that we're going to test the bugs, but it is a very complex and a tedious process. Now in unit testing, what does it mean? Unit, when we are going to develop a big software product, now in that case, what we have we can say n number of modules in a single software product. So we have to test each and every smallest module so that we can ensure a high quality product. So those independent small units will be tested first, and then they will pass to the next testing phase, which is known as integration testing, in which we are going to integrate the two phases, two units together, and then we'll test the integrated product. After the successful integration testing of these two products, another module will be added to the integrated model. And we keep on integrating all the software modules till the time we'll get a developed product. And once all the modules have been tested, have been verified by the unit testing and the integration testing, after that, we have system testing. That means, just give me a minute. After that, what we'll do is, we'll move to the another testing, that is system testing, where the whole system as a you know complete system before delivery will be tested and will ensure the performance of the software product. And after having a successful testing phase, we'll move to the maintenance phase, right? So every after the successful delivery, maintaining the software product is one of the important tasks, and we have to maintain the product on a periodic basis. Next, this is the testing life cycle. Right now, we have studied SDLC. Now, this is basically SDLC. SDLC involves all the vital phases through which a software undergoes throughout the development process. Now, this is testing lifecycle, software testing lifecycle, which starts with project initiation, system study. Now, after that, we have test plan. For every testing procedure, what we have to do? We have to make a test plan, right? That how many modules we have to test, right? We have to assign a test case ID to every test module. After that, we have to design the test cases for every single module, that these are the test cases which are going to be uh, used for this specific module, right? So then we'll execute the test cases either by the manual testing or by using some automated tool like Selenium. Once we'll test those test cases, will report the defects, right? If we're using the automated tools, then the automated report will be generated by the specific tools. If we are using the manual testing, then manual report has to be prepared by the team. And after that, we have the regression testing. Now, regression testing always involves that when we test the module, we'll fix the bug. It should not affect the other modules. Fixing a bug should not affect the other modules at all. After that, we'll analyze the process. And then after completing the testing process, we'll submit the summary reports, that what kind of errors we have undergo, what kind of modules has been facing a number of issues in the testing process. So by using all these things, every important point has to be summarized in the summary report. And this is how the testing life cycle works. Test plan. It is basically a document, or we can say a software, which will generate that how the whole testing process will be executed. The plan typically contains a detailed understanding of what the eventual testing workflow will be, how this whole process will be done. So it is actually a documentation procedure which will involve the test ID, then it will involve the number of test cases for a specific module, then it will involve the duration of the testing procedure and the type of testing, whether we are going to have automated or the manual testing. Next is the test case. It is a specific procedure of testing a particular requirement. It includes the identification of specific requirement tested, test case success or failure, what will be the specific tests to execute that test module, and the test data which we have to test. So everything will be included into the single unit, that is test case. So these are actually the various artifacts of software testing: test cases, test plan, test scenario. These all are the various artifacts which we use in the documentation of the testing procedure, right? Moving further, we have verification versus validation. Now, these terms are so confusing. Verification versus validation. Let's understand the simple mechanism. Verification means when we are doing the process, when the testing is going on. That means verification will be done when the testing process has been, we can say it is going on, right? Now, it actually tells that are we building the product right? Whatever the product we are building, are we building the product right? जो भी हम बना रहे हैं, whatever the product we are making, are we building the right product? That process is known as verification. Now, validation. The software validation always occurs when the software product has been developed. Now, the product which we have developed, are we building the right product? Right? Have whatever we have built, whether we have built the right product or not. So this is validation. There's a thin line difference between verification and validation. Verification means when we are performing the testing, when the testing is going on, at that time, verifying whether we are building the right product or not. Validation is a procedure which we perform after the development of the software product, whether we have what we have developed, whether it is validated, whether that is right or not. So this is verification versus validation. Verification means we are doing the static testing. Validation means we are working on dynamic testing. That means product has been developed. Now we are testing it. We are testing the coding, execution. We are working with the test cases. We are doing manual or automated testing. On the other hand, static testing, verification procedure means that we are not running any test cases. We are just verifying with the document specification documents that whether we are building the right product or not, whether it is conforming to the user's requirement or not. Testing methodologies. Now the whole testing, we can say the procedure was completely divided into two units, that is automated and manual, right? Further, the methodologies which will come under these techniques will be black box testing or the white box testing. So the various levels which we have discussed, unit testing, integration testing, all these testings are completely comes under these two categories, these two methodologies, that is black box testing and white box testing, right? Now, black box testing, in which knowledge of the internal program and design are not at all required. We do not require any design or any code understanding. Tests are completely based on the requirements what the end user has given to us and the functionality, what kind of functionality is being required from the software module. So such kind of testing will be known as black box testing. Next is white box testing. Knowledge of the internal program and design and code required. That means we need a team of developers along with the testers. A main modulator who is technically skilled with this such kind of code is required in white box testing. Tests are completely based on coverage of code, statements, the branches, the paths, the condition we have implemented in a code. That is the main part of white box testing, right? Give me a minute, please. In black box testing, we just need the requirement analysis. We have the input. We will verify with the requirements whether it is going to match the requirement, whether whatever the functionality is being advised by the end user, whether our software product is performing or not. On the basis of that, we'll lay down the report and we'll hand it over to the development team, right? So this is all about black box testing. As you can see in the diagram, there is no code, no need of, you have to undergo with the code. You doesn't require any knowledge of internal design. You just have to verify the input with the output. You will get the input, you will work with that input based on the requirement. If it worked, you will generate the output, else a proper report will be generated and that will be provided to the development team. This is how black box testing works. White box testing involves a complete internal knowledge of the software module. So it involves the developer, people from the developer team as well as from the testing team. Those will test the data, check the component code, and it will generate the test output. It will check all the condition. It will cover every single statement, right? So it will cover all the branches, all the loops, every single statement will be covered in the white box testing. Now, testing levels. As we all know, there are number of, we can say, just give me a minute, please. Now, as we all know, there are various levels of testing that will start from unit testing, then we have integration testing, and then we have system testing, right? Uh, and we'll continue with this topic in the next presentation. Thank you.